Larson, Sustainable Systems Agronomist here, and we're going to talk about soil respiration today. And the two things I want to introduce before diving into this are two major concepts with soil organic matter. And first is that soil organic matter takes many different forms. It can be the living, it could be like the roots in this newly developing cowpea, to all the passive things, the humus. So that's our soil color, that's our more lignified material. But then there's also the active organic matter. And the active forms of organic matter, like coming off the roots here, are polysaccharides. They're easily digestible acids, and these are the things that break down very quickly and are a very important food source for a lot of our soil microbes. So it's very important to know that we just have more than one type of organic matter. Organic matter just isn't one simple thing. It's many, many, many different forms in the soil. And the other important point to make is that our soils are constantly turning over organic matter. We're constantly adding and constantly losing organic matter. And for any pound of organic matter that goes in the soil from the surface or from roots, we're going to lose 60 to 80% of that and only turn in that remaining fraction into soil organic matter. So we're in this constant cycle of turning over our soil organic matter. So one of the ways we can look at organic matter is respiration. And just like us, our soil microbes are bringing in oxygen and breathing out carbon dioxide. So our soils are constantly turning over this level of carbon dioxide. And what respiration can do is it can indicate the supply of carbon to our microbes. We need to have that there to be respired, but then we need the microbial activity. So now that I'm putting some cover crops back in the ground in this some of the plots I have, we're starting to pump that carbon back into the roots, and I'm sure our microbial activity will be picking up here over the next couple weeks. So why respiration then? We know we're having it come off. Why is it so important that we look at something like respiration? Well, as I mentioned before, we have all these forms of organic matter, and that active fraction of organic matter is a very small fraction of our total soil organic matter, 5 to 10% typically. But that 5 to 10% of our organic matter really does a lot in terms of feeding our soil microbes and driving that system and ultimately getting us a lot of the things that we want to have. So we need something that's very sensitive to those changes in active organic matter, and respiration is a good indicator of that because it, again, is that source of energy available to those microbes. Another thing that we're seeing some research on that's actually really interesting is that we're finding that respiration can be a really good indicator of nitrogen that can be available to our soils. Organic matter is comprised of carbon and also has a lot of nitrogen in it, and anytime we're turning over that carbon, we're releasing nitrogen as well. So if we're starting to see that work out there, that work in the scientific literature that's showing that if we can measure this this respiration, it's going to give us an indication of ultimately plant yield, and even be maybe more sensitive than some of our nitrogen measurements, like the pre-sod dress nitrate test or using a chlorophyll meter. There's a lot of ways to measure soil respiration. We can do it in the lab. We can measure the gas coming off. If we're in the field, one of the easy ways to do it is through something like our Solvita kits. So these kits have basically a small paddle here, and on this is a gel that starts to measure the carbon dioxide that's evolved. So we want to place soil in these containers, place in the paddle, cover it, and let it sit for a set amount of time, typically 24 hours. And at that point in time, we can make some comparisons and make some inferences. And we're doing that by using the indicator chart here on the left, and that gives us a standard we can look off of and make some decisions here. So I brought two soils with me. First one we have is one that's been in a pretty good rotation of cover crops, no-till, and has been in that system for a while. So we can see here that we have a relative value, probably somewhere in that 3.5, 4 range. And we also have some that are from more of a transitioning scenario where we're just getting into cover crops, just getting into away from conventional tillage. And you can see here we're probably a little bit higher. So we have, reasonable enough difference between those two units there. And I'd say that's what I would expect to see in a scenario like this. This new field certainly wasn't used and abused, but I would not expect it to be functioning as well as something that's been in a cover crop system for quite some time. So we can make those inferences in ways we can possibly use the Solvita test because it's measuring that active carbon. I would be using it to compare against a reference state, kind of like what we're doing here. You could pick a new field that's transitioning and try to compare it with your field that's been in cover crops or no-till for quite some time, compare it to pasture, compare it to something similar that you want to use as a reference as what you would believe to be a really healthy soil. And my suggestion is to take those measurements about the same time every year. Getting them when your cover crop's coming out and kind of planting your cash crop. Or are you doing it in the fall just when you're starting to plant something? I would be taking those snapshots about the same time in your phase in your rotation. So it can be nice to make some inferences and learn a little bit probably before it's going to show up as organic matter on a soil sample. So I think that's a nice way to use this test, is kind of see those early changes that we would have in terms of our soil organic matter. And the other change, because we're starting to see these things with nitrogen and this being a good indicator of nitrogen, is to take a few of these samples early in the year, as soon as planting, or even your typical time for doing a pre-side dress nitrate test. So, when the corn's about 1 foot to 18 inches tall, V5, V6, take some there and compare that to what you're doing if you're doing those adaptive management techniques, like using a chlorophyll meter, like using PSNT, maybe even stalk nitrate testing, something where you can make some inferences based on other methodologies you're using to define your nitrogen program. So I think 2 interesting ways we can use Solvita to kind of gauge ourselves and also start thinking about making management decisions. I don't know if we're quite there yet, but I would start playing around with it to see where it might tell you something on your farm. And remember too, these tests are as good as the sample that you take, so make sure you're following the directions that you need to follow when you're doing this. But again, this can be a really great tool to give us those measurements that may be a little bit more sensitive or might be offering a little bit more insight than we typically have. So there's places for this on our farm, certainly, especially when we're trying to see those quick changes and differences in management as we change our systems and adapt things like cover crops, no-till to our operation.